Hi and welcome back. In the previous video, I've just shown you how to solve LeetCode 139 word break. It's a medium problem, dynamic programming. And we came up with a solution that allows us to solve an O of n times m times k time and O of n space. And in that video, I said that I would show another implementation based on a trie that allows us to bring down the complexity needed for space. Right, so, well, how do we do this? Well, the naive approach, or the straightforward approach, was use a recursive helper function, and we're going to perform a string match at every position against the words in the dictionary. By the way, recap real quick. So what we have is we have a string s, and we need to break it into words, and we can only use words that are in our dictionary. We can use them multiple times. And the question is whether we can break down a string into substrings using those words, right? So LeetCode can be broken down into leet and code. So that's why we return true. Apple, pen, apple, same thing. We match apple, pen, and apple. Then we have a negative example here where we can't break the string s up into words because, well, we don't have all of the required words that we need to do so. Right. I recommend you check out the previous video to understand the problem more. This video really just focuses on a more efficient implementation for the string matching part. So in our algorithm, we iterate over all of the words from an index position, and we check whether the word is a match from that index on. And if it is, we go into the recursive call, etc., etc. So how can we optimize this? Well, I said a trie, right? So we're going to get rid of our starts with method for the string matching, and we're going to get rid of our loop over the words. So those are two things that we're going to replace. Now, the first thing that we need in order to solve any problem with a trie is to build one. So I'm just going to show you the shortest and quickest way to build a trie in Python. You don't need a fancy class, nothing of that. You just need a dictionary, and then you iterate over all of the words in your word dictionary in word dict, right? And then you just pick the trie. That is going to be the trie. So we pick the root of the trie here. And then we just start iterating over all of the characters in words. So for C in word, we're going to say if C in trie, well, if it's not in there, we need to put it in. Not in trie, we say trie at position C is just another dictionary. Now, then we need to, I guess, descend in our trie. So we're just going to say the trie is going to be trie for that character. So we are going down the nesting, and we're making sure that at every level we add a new character that is in word if it doesn't exist. Now, when we're done with this, we basically need to mark this position in the trie as, well, this is a position where we actually have a word, right? So we need to pick a marker, and it's advisable, since we're iterating over single characters, to use one that contains more than one character, so that you can distinguish it from other possible characters. So I'm just going to pick end of word, basically you know. So, well, yeah, that's your trie. That's it. That's all you need. And in our helper method, instead of iterating over all of the words, what we now do is we just, we try to match the characters in S against, well, we try to match the characters in S against our trie. So what we're going to do is we're going to say trie. We're going to pick the root of the trie again, and now, well, we can still descend in our trie, and our position I is smaller than the length of S, right? Both are conditions that, well, basically we don't want to go above the length of the string with our variable, our index I, and we want to make sure that we can still find something in the trie. If one of these cases isn't true, that means we have a no match situation. We should just return false. Right, so, well, what we do now is, well, we get the character position I from the string, and now we just check if C in T. That means, oh, we have the character in our trie, and we can, well, we have a match for our next character. That's awesome. So in that case, we go into advance. We also need to increment our I at this position, by the way. And then what we do is we check if end of word marker is in trie. That means at the current position of the trie, we have a prefix match for a word in S from our initial position I, which we've incremented in the meantime. So if that is the case, well, we can call our recursive helper function. Super simple. So if at position I, because we already incremented our I here, if that is true, return true. That's it. We found a match. We're done. Now, if this is not the case, so if the character is not in T, well, that means we didn't find a match for anything. So we're just going to break out of this, of the while loop, and we are done, right? And we could just say not in T. If C not in T, break. That's what we do as well. Makes it a little bit simpler, I guess. Yeah, and well, that's pretty much it. So let's just run the test cases, see if I have any typos or anything. No, so the test cases pass. I'm also going to submit this to check all of the tests. And that works as well. And well, now, how much better did we get with the runtime? Well, let's think about this. So we have, what is our time, what is our space? Well, now building the trie costs some amount of time, right? So we have to iterate over all of the words, over all of the characters, right? So we could maybe say L is a total number of character, or, well, sum of word length in word dict, right? So we definitely need L time to build the trie, right? And the worst case, that's also, I guess, the space that we will need. Right? We need to store all of these characters in our trie some way or another. And but we also need to call our DSS helper method. So, and we're caching stuff for it. So that means at most we're going to cache n values for our helper. N would be the worst case, where n is, of course, the length of a string. So of L plus n time is going to be our space complexity. And our runtime complexity is, well, creating the trie, plus now we have to consider, how expensive is it to do all the matching. We know that because of the caching, we're going to at most call our DSF helper n times, so we still have our factor n. But now, what is the k, right? So, well, k would be another variable that we have to have, which is the length, or the max length of any word in word dict. Because if we do the matching here while we iterate through this, the maximum number of steps in our while loop is k. So that's why we have to have the factor k in here, right? So yeah, and so the nice thing is now we don't have a component where we always have to loop over all of the words in our word dictionary. So we've, if the length of the dictionary is larger than the word length in the dictionary, that's definitely going to be a massive improvement. And also we don't have the string matching part anymore, where we have to actually start trying to match the entire string against a word that is potentially not even in the, there's potentially not a prefix to the remainder of the string from position I. So yeah, I kind of like this implementation. It's really cool. Yeah, you should have a look at the other video and maybe try to implement both ways, just to get some practice with it. All right, thanks very much for watching.